Okay, adding and subtracting rational expressions. So adding and subtracting rational expressions is just adding fancy fractions. Okay, adding and subtracting rational expressions. So adding and subtracting rational expressions is just adding fancy fractions together. Okay, so let's remind ourselves how to add fractions. So when we're adding fractions, remember the key thing that you need is a common denominator, right? So before I even get into this, let me just go to an example. If I wanted to add 2/5 plus 7/5, right? I'm allowed to combine those and add those together because they have the same denominator, right? They both have 5 as the denominator. When I add those together, you just add the numerators, 2 plus 7, and I get 9/5 as my answer. Remember, you do not add the denominators together. It's just going to stay as 5. Okay, so it's very similar when we have rational expressions, except now you have variables in your denominators and not just numbers. Okay, so your like denominators are when each denominator has the same factors, not the same terms. So what I mean by that is, let's say I had something like 1 over x plus 3. Well, then I would need another term that has x plus 3 in the denominator. Now, something that would be not like denominators would be like 1 over x plus 3 and then 2 over x plus 6. Okay, do you see how these aren't matching completely? Well, then these are not like denominators. Okay, another example, 5 over 2 times x plus 7. I would need another 2 times x plus 7. Okay, so they need to match exactly and entirely. Okay, so I'm just going to start right away with combining ones with like denominators, and then I'll get to the steps to when we don't have the same denominator. Okay, so in number 1, I notice right away that they both have the same exact denominator. So I'm going to go ahead and combine the numerators. There's nothing I need to change from the fractions. You're already allowed to combine them. Just like that first example with the 5s in the denominator, the 5s were the same, so you're allowed to combine the numerators. So when you're combining the numerators, you're literally just adding these together. Well, remember, you have to add like terms. So I can only combine the x with the 2x. Remember, that doesn't become 2x squared. You're not multiplying. We're just adding, so that becomes 3x, right? You combine the numbers in front of the x. Then I need to combine the 4y and the negative 6y. So that's 4 minus 6. That's negative 2y over 12xy. Now, after you combine, you need to make sure you can't simplify. So this goes back to our very first lesson with rational expressions. When we were simplifying. So I need to look and make sure, can I factor anything in the numerator? No. I can't factor the denominator. Nothing matches completely, so I can't cross anything out. So this is my final answer. Okay, same thing with number 2. The denominators match exactly, which means I could go ahead and combine right away. Again, I'm just going to combine the like terms in the numerator. So 6r and r match. So that's going to become 7r. Then I have negative 1 and negative 6. That's negative 7 over 5r squared minus 21r plus 18. Okay, notice that I didn't change the denominator. Okay, I mean, I didn't combine the denominator. It stayed exactly the same. But now I have to look to simplify. I could see that I could factor in the numerator. There's a GCF of 7. So I'm going to take the 7 out, and that becomes 7 times r minus 1. And then I'm going to factor in the denominator. Now, there is no GCF. So the only way you could split up the front of your parentheses is 5r and r. Remember, this is reverse FOIL. So if I were to FOIL this out and I multiply 5r times r, I should get back to this term 5r squared. Okay. And then I have to guess with factors of 18. and it's going to multiply to be a positive but add to be a negative, so that means my two signs have to be minus, minus. And then again, I got to test with factors of 18, so I could use 3 and 6. I'm going to try that one, 3 and 6. And remember, when we check, we have to multiply our outsides. That's negative 15r. Our insides, that's negative 6r. Combine them. And I need to make sure that this term matches this middle term over here, which it does, so I factored it correctly. Okay, if you forgot how to factor, please refer to some videos, just looking up factoring by guess and check. I notice a lot of us are trying to use Photomath, which is using a different factoring method than we do. So again, if you forgot how to factor, please look up some videos on how to use it, guess and check, because we will be using factoring a lot. Now that I've factored, I don't see anything that matches completely, so there's nothing I could cross out. So this is our final answer. Your worksheets might leave your answer like this, which is totally fine. Either answer is acceptable. The reason why the step previous might be listed as your answer is because the computer already knows nothing's going to cross out. Okay, but either way, I would accept either answer, factored form or not factored form, totally up to you. Okay, number 3, we are now getting into subtraction. Okay, when you are subtracting, you have to be very careful because you are subtracting this entire thing from the first fraction. Okay, so what you need to do is change it to addition and distribute the negative to the numerator of the second fraction. Okay, well, there's not really much to distribute in the second fraction since there's only one thing in the numerator, but just to keep in good habits, make it a plus, put the negative in the next numerator. Okay, so I already have common denominators, so I'm not going to fuss with those, which means I could go ahead and combine my like terms in the numerator. So nothing combines with p, so that's going to stay. And then I have negative 6 and negative 3. That's negative 9 over p squared minus 36. Now I need to make sure that nothing's going to simplify. So I got to factor where I can. I can't factor in the numerator, but I can factor in the denominator. Remember, that's a difference of 2 squares. So that means when I factor, I still go into my 2 parentheses, but I take the square root of p squared, that's p. Take the square root of 36, that's 6. 1's plus, 1's minus. I'm not seeing anything match completely, so then that's my final answer, or this could be your final answer as well. Okay, number 4, I'm noticing that I do not have a common denominator, so I need to figure out how to do that. Okay, so since these are monomials, there's no addition or subtraction in the denominator, I don't have to factor anything. So what you're going to do is you're going to think, how can I make these denominators look exactly the same? Okay, a denominator you can't take away anything from a denominator, you could only add things to it. So what that means is I need this to keep the y. I can't get rid of the y, and in this one I can't get rid of the x. Okay, so what I'm going to do first is just look at the two numbers and ask yourself, how can I make 3 and 6 match, right? What's a common denominator between 3 and 6? I'm going to call this CD for common denominator. So I know between 3 and 6, I can make them both match at 6, right? I can't make a denominator smaller, so I can't make them both match at 3. I can't divide the 6 by 2. You can only change them by multiplication. So I could make them match at 6, and since this one has an x, I need an x in my common denominator, and since this one has a y, I need a y in my common denominator. Okay, they need to have the same variables. You can't get rid of them. You can only add on to them. So once you figure out what your common denominator is, you need to ask yourself, how could I change this denominator to look like this denominator? Well, this one already has the 6x. From the common denominator that I decided, it is missing y. So to get it to have the y, I got to multiply by y. But what you do to the denominator, you have to do to the numerator, okay, to keep it balanced. So now I'm going to have 5xy in the numerator, And now in my denominator, I have 6xy. Okay, I'm going to use the same thought process for the second fraction. So how can I make this denominator look like my common denominator? Well, I can multiply 3 by 2. It already has a y, but the only thing I'm missing from the common denominator is the x, so I'm going to multiply by 2x. And what you multiply by the denominator, you have to multiply by the numerator. So in the numerator, I get 6x, and in the denominator, I get 6xy. Okay, now that the denominators are exactly the same, I could go ahead and combine the numerators. Well, these aren't actually like terms because they don't both have xy. So I'm just going to write it out as one whole thing. So 5xy plus 6x, again, you cannot combine them. So you write it as is. And then my denominator is 6xy. Now remember, you can't just cancel things out from pieces of each binomial. So since the numerator is a binomial, it either has to cross out as a whole or you can't touch it at all. Well, I don't see a 5xy plus 6x in the denominator, which means you can't simplify any further, and that's your final answer. Okay, and number 5. So to decide my common denominator, I'm going to look at just the numbers first. And if it's hard for you to find a common denominator between two numbers, you could either, 1, multiply the two together and you'll get a common denominator. So 4 times 3, that'll be 12. Or you could start with the smaller number and start listing out multiples. Okay, so since 3 is the smaller number between 3 and 4, I'm going to start listing multiples of 3, essentially counting by 3s. So 3, 6, 9, 12, and you're going to go until you find a number that you could divide the second number by. So I'm going to keep counting by 3s until I find a number that's divisible by 4. Well, that's 12. Okay, right, 12 divided by 4, that gives me an even number. So I know that they have 12 in common. Okay, and then I'm going to look at my variables. So my variables can't become smaller. So if this is m squared, I need an m squared over here. Okay, so the common denominator between the m's is going to be m squared. So when you're finding the common denominator between variables, you pick the bigger exponent of the two. Okay, so between 2 and 1, 2 is the bigger one. It's got to be m squared. And this one also has an n, which means my common denominator also needs an n. Okay, you're kind of just filling in the gaps. What is one missing that the other one has? Okay, so I'm now looking at my first denominator. I see it already has the m squared n that my common denominator has, so I don't need to worry about changing the variables, but I do need to worry about changing the 4 into a 12. So I'm going to multiply this by 3, and what you do to the denominator, you have to do to the numerator. So this becomes 9n over 12m squared n. Okay, and then you got to ask yourself in the second fraction, how can I make that denominator be 12m squared n? Well, I know I can multiply by 4. And then how can you make m squared? Well, you can multiply by m, and we're missing that n, so I'm going to multiply by n as well. And then multiply the numerator by that. I'm sorry, I forgot to make this addition and then distribute your negative. So I'm multiplying negative 2 by 4mn. So that becomes negative 8mn over 12m squared n. Okay, now my denominators match, so I'm going to combine the numerators. However, those are not like terms, so I'm just going to write them as is. And then in my denominator, 12m squared n, right? You don't combine your denominator. I'm going to look to simplify. I don't see anything I could factor, anything I could cross out. So then that's your final answer. Okay, last one with the monomials. I'm trying to find a common denominator between 4 and 5 first. So again, if you can't figure out the smallest common denominator, you could start with the smaller of the numbers and count up. So 4, 8, 12, still not divisible by 5. 16, not divisible by 5. 20 is divisible by 5, so that's the common number. Or you could just multiply 4 times 5 and you'll get a common denominator, which would give you 20 as well. Okay, then I have to look at my variables. I have an x squared and I have an x. Well, you have to pick the bigger exponent between the two, so it's got to be x squared because you can't make a denominator smaller. And then I have a y and a y squared, so I need it to be y squared as my common denominator. Okay, so ask yourself, what can I multiply 5 by to make it 20? Well, that's 4. This already matches the x squared here, so you don't need to change that. But I do need y to become y squared, so I'm going to multiply by a y. Okay, so in the numerator I get 24xy. In the denominator, I just created my common denominator of 20x squared y squared. Okay, and you're going to do the same thing for the second fraction. So I need to multiply by 5 to make the 4 a 20. I need the x to become x squared, so I need to multiply by an x. And the y squared already matches the y squared in the common denominator, so you don't need to fix that part of the denominator. So in the numerator, I get 15x squared over 20x squared y squared. Okay, so I'm going to combine the numerators. They are not like terms, so you write it as is. And then my denominator is 20x squared y squared. Remember, you don't combine your denominators, you keep those the same. I see that I can factor, right? I'm looking to simplify. There is a GCF in the numerator. Okay, they both have x in common, so I'm going to pull out an x as a GCF, and that becomes, 3x I could actually pull out. So that's going to become 8y plus 5x over 20x squared y squared. Now that you factored this out as a GCF, it is not a part of the binomial anymore, and you could simplify that with the monomial in the denominator. So the x's can actually simplify with each other. So I'm going to cross out this x, and this is just going to become 1x. So my final answer is going to be 8y plus 5x over 20xy squared. Okay, you could redistribute the 3, but that's just extra work. You don't have to. You could just leave your 3 factored out as is. But if you want to multiply it in, you can. Okay, number 7. So when people are trying to find the common denominators with problems like these, you guys usually try to change the 5 and the 3, and you're like, oh, well, those can match at 15, so I'm just going to multiply this by 3 and multiply this by 5. Well, that wouldn't work because that would become 3r plus 15, and that would become 5r plus 15. See how those don't match? So you can't look at it like that. You have to look at your denominator as a whole, right? Remember, your binomials are package deals. So that's one whole thing, and this is one whole thing. Okay, so all you have to do to create your common denominator is put the two binomials together. Okay, so one binomial has an r plus 5. One of the denominators has the binomial r plus 3. That's your common denominator. Okay, so essentially all you have to do is multiply the fraction by the binomial that it's missing. So, or the other binomial. So this one has r plus 5. It's missing r plus 3, so I'm going to multiply by r plus 3. And remember, what you have to do to the bottom, you have to do to the top. So when I'm multiplying by r plus 3 in the numerator, you have to make sure you distribute. Okay, so that becomes 4r plus 12. Do not distribute in the denominator. You're just creating so much work for yourself. Leave it as the two binomials in the denominator as is. So only distribute in the numerator. Okay, and here I see it's subtraction, so I'm going to make that addition and make that 4 negative. Now I have r plus 3 over here. I'm going to multiply by the other denominator, which is r plus 5. And then you have to distribute. So that's negative 4r minus 20 over r plus 3, r plus 5. Again, only distribute in the numerator, not the denominator. So now that the denominators are exactly the same, you're going to combine your like terms in the numerator. So I have 4r and negative 4r. So those cancel each other out. And 12 minus 20, that's negative 8, over r plus 3, r plus 5. I don't see any binomials that match. I don't see anything that's going to simplify, so that's your final answer. Okay, I'm going to skip number 8 right now. I'm going to do 9 and 10 first and then go back to number 8. So number 9, just like number 7, so the common denominator is a plus 2, a plus 5. Okay, let me write that. A plus 2, a plus 5. So it's just the two binomials put together. So all you're going to do is multiply this first fraction by the other denominator. So I'm going to multiply by a plus 5, distribute in the numerator. So I get 3a plus 15 over, and then do not FOIL in the denominator. Leave it as a plus 5, a plus 2. Okay, same thing for the second fraction. I'm going to multiply by the other denominator, so I'm going to multiply by a plus 2. And then you're going to distribute in the numerator, so 2a squared plus 4a over a plus 5, a plus 2. Okay, now that the denominators match, you're going to combine your like terms in the numerator, so 2a squared plus 7a plus 15 over a plus 5, a plus 2. And then you want to try and see if you could factor in the numerator. Okay, and to figure out if you could factor the numerator or not, this is what you're going to do. You're going to look at this first, let me make this bigger. You're going to look at this first number and this last number, and you're going to multiply them together. So you're going to take 2 times 15, 30. Okay, and then you're going to ask yourself, are there factors of 30, so things that multiply to be 30, that also add to be 7? So we have 2 and 15, that doesn't work. 3 and 10, that doesn't work, that adds to be 13. 5 and 6, that doesn't add to be 7. So since there are no factors of 30 that add to be 7, the numerator is not factorable and you cannot simplify. Okay, so your final answer is just going to be what you see here, 2a squared plus 7a plus 15 over my new common denominator. Okay, number 10. So all you're doing is combining the binomials to make one big denominator. So k plus 6, k minus 1, and no, the order doesn't matter because it's multiplication. So you could have k minus 1 first if you want. Okay, so all you have to do is multiply by the missing binomial. So what's important about this one is I have a binomial times a binomial, okay, which means we have to FOIL. Okay, so in the numerator, remember it's first, so that's 4k squared, and then you got to multiply k times 1, that's your outside, so 1k, then your inside, so that's 24k, and then your last, so that's 6 over k plus 6, k minus 1, plus, now in the second one, right, we got to multiply by k minus 1 by the top and bottom. And here we just have to distribute, because it's not a binomial times a binomial. So 2k squared minus 2k over, and do not distribute in the denominator. Do not FOIL in the denominator, only FOIL in the numerator. Okay, now I'm going to combine all of my like terms. So I have 4k squared plus 2k squared, that's 6k squared. Then 1k plus 24k, that's 25k. Minus 2k, that's 23k. And then just the 6. So I'm going to add on the 6 over k plus 6, k minus 1. Okay, now to make sure I can factor, I'm going to multiply 6 times 6, that's 36. So I got to think of factors of 36 and see, do they add to be 23? So 1 and 36, no. 2 and 18, no. 3 and 12, that adds to be 15, no. 6 and 6, no. 9 and 4, no. None of those add to be 23. So you cannot factor the numerator, which means you cannot simplify any further. And that's your final answer. Okay, now I'm going to go to number 8. So before we figure out our common denominator, you need to factor. Now, a lot of people would just think, well, why can't I just combine this denominator and make one big one? Well, that's because sometimes you'll have binomials that match within this trinomial. So what you need to do is you need to factor. Okay, remember when we factor, you go into your 2 parentheses, so we're reverse foiling. And I have a 2 in the front, so I'm going to break that up as to 2n and n. And then factors of 1, well, that's just 1 and 1. And I'm going to do minus plus because it's multiplying to be a negative. So let's check. Negative 2n plus 1n gives me negative 1n, which is the term in the middle. Okay, so I factored that correctly. So I'm going to cross this out. So this is my new denominator for the first fraction. Well, hopefully you're noticing that this matches with this. Okay, so we already have an n minus 1 in both of our denominators. But remember, you can't remove anything from a denominator. So think to yourself, well, if this one has a 2n plus 1, well, this one's missing the 2n plus 1. So I need that as my common denominator. So the common denominator is 2n plus 1, but they both already have the n minus 1. Okay, so the first fraction already has the common denominator. So I'm going to keep that one as is. I'm not going to multiply by anything. But the second fraction only has the n minus 1. So what it's missing from the other denominator is the 2n plus 1. So what you have to do is just multiply by what it is missing from the other denominator. So I'm going to multiply by 2n plus 1. Make sure you distribute. So then I get 10n plus 5 over. Do not FOIL in the denominator. Okay, leave it as 2 parentheses. And now you're going to combine your like terms. So only in the numerator. So n plus 10n, that's 11n. Negative 2 plus 5, that's 3 over 2n plus 1, n minus 1. Nothing cancels. Nothing can be simplified. So this is your final answer. Okay, on to number 11. So before I even factor, because again, we might have matching binomials once I factor, so don't just combine the two right away. Factor first, but I'm going to make this addition and distribute that negative first. Okay, and I'm going to factor the second denominator, so k and k, and then it's got to multiply to be positive 25, but add to be negative 10, that's minus 5, minus 5. So I'm going to cross this out. My parentheses are my new denominator. Well, notice that this one has 2k minus 5s, and this one only has 1. Well, we need 2 of them. I can't take 1k minus 5 away, so these technically aren't matching yet until the other fraction gets a second k minus 5. Okay, so in this case, the common denominator is 2k minus 5s. Okay, so I need 2 parentheses that say k minus 5. Well, this first one only has 1, so I got to multiply the first one by a second k minus 5. Okay, well, unfortunately I have a binomial in my numerator in the first fraction, so you have to FOIL again. So k times k, that's k squared, plus 2k minus 5k minus 10 all over k minus 5, k minus 5. Well, the second fraction has my common denominator already, so I don't need to multiply by anything. That one doesn't need to change. So I'm just going to rewrite it as is. Okay, and then I'm going to combine my like terms in the numerator. So I have k squared, 2k minus 5k, that's negative 3k. And then you have negative 10 minus 3, that's negative 13, over k minus 5, k minus 5. Okay, let's see if we could factor this. So 1 times negative 13. So are there factors of negative 13 that add to be negative 3? No. So then this is your final answer. Okay, and then finally number 12. So I got to factor my denominators first where I can. So this first one I can factor. So 2k in the front. It's going to multiply to be a positive, but add to be a negative, so minus, minus, and I'm going to guess with factors of 12. So I could do 1 and 12. That won't work. I could do 2 and 6. 2 and 6 won't work because if I put 2 here, I have a GCF. If I put 6 here, I have a GCF, so no matter what, if I multiply it out, it's not going to add to be 11. I could do 3 and 4, but the 4 has to go here and the 3 has to go here because 4 has a GCF with 2. And now let's check. Negative 8, negative 3, that adds to be negative 11k, which is my middle term, so I factored that correctly. Okay, notice that they both have 2k minus 3, but what does this one have that this one doesn't? Well, the k minus 4. So my common denominator is 2k minus 3 and k minus 4. So my first fraction already has what it needs, so I don't need to multiply by anything. I'm just going to keep that as is. But the second one is missing k minus 4, so I got to multiply by what it's missing. So I'm going to multiply by k minus 4. So I get 6k minus 24 over 2k minus 3, k minus 4. Okay, we do not simplify to the very, very end, so you have to combine your numerators first. So combine your like terms, 3k plus 6k, that's 9k, minus 24 over 2k minus 3, k minus 4. Now let's see if we could simplify. So I see that we could factor out a GCF in the numerator, so I'm going to take out a 3. I get 3k minus 8 over 2k minus 3, k minus 4. No binomials match, can't cross out the 3 with anything, so this is your final answer, or you could have left your answer like this. Okay, and that's it for adding and subtracting rational expressions. I know this is like the least fun topic to learn, and it can be a bit confusing, but please feel free to email me if you have any questions. But since we only have very little class time left, we're just going to have to keep moving on. So again, please let me know if you are confused on anything, and then we could talk about any questions you may have.